Today I'm going to demonstrate for you the detection of melamine in a milk sample using electrospray ionization in our GA2100 high-performance ion mobility spectrometer instrument. With this simplified procedure, the first thing we do is take a 1 milliliter sample of the milk and put it into a clean vial. And then to denature and crash out some of the proteins, we're going to add 3 milliliters of a 1 molar aqueous acetic acid solution. And then we will let this sit as the acid begins to crash out some of the proteins. And then we are going to take a sample from the top of 200 microliters of the liquid and transfer it to another clean vial. And to this vial, we're going to add 2 milliliters of the acetonitrile. An important step after this is then to use a vortexer and to vortex for 1 minute. You can see that the large white clumps of the denatured protein that are settling out to the bottom. We're going to be using a 0.22 micrometer pore size nylon syringe filter for filtering out the proteins. It's got a lure lock, so it attaches to a disposable high-density polyethylene syringe. Most of them have settled. So I will use the syringe to remove the liquid from the top, carefully avoiding the particulates at the bottom. This will also allow us to minimize how much sample we lose and get us the highest extraction of sample for filter. I can then exchange the needle for the syringe filter, which I will then use to filter the matrix, which after this step provides us with a greatly cleaned up milk matrix sample of about 2 milliliters. This is the sample that we're going to use as our blank milk matrix. It has roughly a composition of 90% acetonitrile and 10% of the milk matrix with the acid from the denaturing step. We are now going to take 250 microliters samples of the milk matrix, and then we're going to spike it with melamine. So I'll now use our melamine stock solution to spike our milk matrix, and then we'll be able to take these samples over and analyze them using the GA2100.